We're moving on, right, sir?
With Viasat, our presenting partner, David.
Yes, sir.
Yes, indeed, and most grateful for their kindness, their generosity, and their involvement. Certainly.
Hello, Colonel. How are you, sir?
Good afternoon. Thank you. Great to be here.
Good. It's Colonel Fred Taylor with Viasat, Vice President Space and Cyber Applications. He's going to be hosting moderating a discussion with Dr. Joel Mozer of the U.S. Space Force, the Director of Science, Technology, Research at the Pentagon. And we really appreciate your being here today. We appreciate Viasat's support and leadership on this program and all the times that you guys have sponsored these events in the past. We're really thrilled that you're going to have a conversation with Dr. Joel Mozer. We're really looking forward to that. We want to thank you both for being here.
Thanks, David.
We'll turn it over to you, sir.
Oh, well, thank you. Dr. Mozer, good to see you. We are excited to have an opportunity to have a conversation, and it's good to be together once again. I think that as many of you probably already know Dr. Mozer, and as he's filled his new role, you can probably explain it better than I am, but just so that we're all tracking that he is the United States Space Force Director of Science, Technology, and Research. Big job. So for a new service, as being the first director of S&T, there is a lot of things that are in your job jars. We try to move fast and try to get after the threats. But he comes well qualified. So with more than 30 years of government service, he has served in a variety of different applications. He is a physicist, actually. Growing up from being an Aggie at University of New Mexico State down in Las Cruces, great place, and then became a Wildcat and got his doctorate and continued doing a lot of different work in different applications across New Mexico, Air Force Research Lab with the Army atmospherics, radar programs, small sat programs, experimental satellites. I can go on, but it is a vast career and a lot of experience and a lot of expertise. So we are excited to have that conversation today. I think we will look at really what space science and technology means for creating that resilient architecture. How do you get after the threats? How do you get capabilities in the hands of warfighters faster? And what are some of the challenges that you're facing? With that, I'll start the conversation, and over to you, Dr. Mozer.
Well, thank you, Fred, and I appreciate the introduction. I appreciate the invitation to be here and have this conversation with you. I'm looking forward to it. So thanks again.
Well, sir, I think that having you here and having our audience, I think maybe just to go ahead and level set some things, what is science and technology? So it's easy to say there's some science and there's some technology. So what does that mean for you and in the Space Force?
So somebody once told me, and I'm pretty sure it was an engineer, that said if it's biology, it's squishy. If it's chemistry, it stinks. And if it's physics, it doesn't work. So I'm pretty sure that was the engineer that told me that. I think I tend to, we often lump science and technology together and call it S&T and think about it one thing, but it's really two very distinct things. Science is all about exploring the options and diving into the complexity, asking why something is, looking for phenomenology, a lot of questions like that, and it takes a whole mindset to do this kind of thing and definite investments. And technology is what we hope to get out the other end eventually. That's providing kit to our warfighters and something that they can use. But there's a lot in between those two areas. Transitioning stuff from the realm of science to the realm of technology is non-trivial, and it's something that we have to manage, and we have to be very careful about our investments that we make. Science is really about providing options for the future. We're investigating, looking at different ways things work and why they are the way they are. Not everything that a scientist investigates will eventually be put into use, but the technologist will figure out what are the most appropriate things to apply. But a lot of times science is people get frustrated with it because it sounds like it's a sink of money and people are throwing money at science and there's really no application. But without science, you wouldn't have those options in the future when it comes to pass, and that you need these things. So very important work that we do.
Yeah, absolutely. As a young engineer, back when I actually did math, the science was always a tough part, and getting the result and on the back end of actually getting to a product or getting a capability I kind of liken back in here from a Viasat perspective. There's always a better way, and you can do this forever to always find a better way. But really, S&T is hard. In technology and getting new technology out to the warfighter, out to the field, out to the commercial market is difficult. So what do you see as kind of the biggest challenges that you have from accelerating and maturing some of those key technologies?
Yeah, and there are a lot of challenges that we deal with, and it really is that transition part to figure out, of all of the different possibilities and options that science provides, which ones are the ones that have the return on investment that are worth investing in, and which ones are higher risk than others. One of the things I like to say is when you're trying to decide what to put your bets on in science and technology, first of all, you got to set your time horizon right. You got to realize that it does take time for science to mature, science and technology to mature. But that kind of counterintuitively allows you to be more agile in the moment. So, a skier doesn't go fast down the side of a mountain by looking at the tips of his skis. He looks way out in front of him, and that allows him to maneuver more. And so that's the real challenge, is being able to have the strategic foresight to think what are the needs and the challenges going to be 5, 10, 15 years when this investment in science actually pays fruit. So today, we're facing a lot of no kidding efforts that we need to apply technology to. For example, we put up most of our satellites back in an era when it was uncontested and permissive, and today we have to worry about folks trying to deny us those services, and we have to build resilience on our systems. Had we thought about this 15 years ago, it would be simple. We would have that resilience built in, but now we're having to redesign our architectures and figure out how to do it. And so that's where the rub lies and where the challenge is. Another area today, the Space Force is very exciting time to have a military branch dedicated to space and operating in space. But we're very small. We're extremely small compared to other services. We're just a few percent of the size of the Air Force, and a very small percentage of the size of the Army. So we have to learn how to do things in the most technologically complex domain, space, the most vast space, is infinite, with a very small number of people. So autonomy and automation, human-machine interfaces, trust in our autonomy, all of these are areas that we're really concentrating on today to really shore up and be able to do the operations that we need to do.
Thank you. Well, it is definitely a big challenge, and working in a domain that is very unforgiving. What do you see from that technology challenge? What are the biggest technological challenges that you're facing in the Space Force, and how are you addressing those?
So part of it is really the rate of change of technology and trying to keep up with that. So the ability to harness the great ideas that are coming not only from our own research labs, but from commercial industry and civil space, and figure out how to put those into an architecture that we can live with and that will extend into the future is a big challenge. And that plays out all over the place. Just an example, the cost of launch has gone down dramatically over the last decade, and we can put things into orbit at an order of magnitude, and sometimes 2 orders of magnitude cheaper than we could have done it just 10 years ago. And that drives a lust to things like very large LEO constellations, lots of distributed systems, which is a good thing, but that's driving new architectures, and we have to work through the details of those architectures. We get, in my position, I see just fantastic, eye-watering new ideas, innovative ideas from commercial entities almost every day. And we would love to be able to implement those, But if it drives a complete change in the way of doing business, that's a significant thing that we must consider. And if it doesn't fit in our architecture, sometimes we have to say no to some of these technologies. But if it does and it has the return on investment, then we have to figure out how to redesign everything and to do things to do the .mil PF, to have the operators, to have the resources to make it happen, have all the downlink connections. So a lot of the technology challenges that we face are really kind of fundamental and architectural in that way, trying to get these new, rapidly evolving ideas into the system in a way that makes sense and it's not utter chaos.
Yeah, well, I can see, new capabilities in the architecture. How do you depart from this legacy architecture to get to more resilient architecture? The Chief of Space Operations constantly says we need to go fast, we need to move faster. So what does it mean to move fast? And really, science takes time, and it takes a lot of effort, a lot of research, and with that, there's inherent risk. Sometimes there's speed with risk, there's sometimes risk in terms of investment, risk based on the threat. So how is the Space Force trying to accelerate some of these S&T approaches, especially when you have a historical approach on S&T in the Air Force that is really tied more to programs of record and that short-term focus?
Yeah, and that's an excellent question. And we are historically a very risk-averse group of people. Our culture is that way because launch was so expensive. We tried to put so much stuff on each individual satellite. They ended up being billion-dollar, very big chunks of national treasure, and we had to absolutely positively make sure that they made them to orbit. So the mission assurance that would go into that was just crazy high. That dynamic is changing, and it like any culture, we have to figure out how to move to another sort of risk posture in our way of doing things, and this is where science and technology can get interesting. One thing that I like to look at risk, which is probably a little different than the rest of the acquisition community, is the risk of not doing something. So, there are certain options that come to mind, and developing, for example, hybrid satellite systems that could do things differently than our legacy systems, or systems that extend out to cislunar space, or these are concepts that people think about, and we think about the risk of doing such a thing. Well, it could be just a lot of waste of money if we don't actually end up needing that from a warfighter perspective. But if you look at it from what's the risk of not doing something, and just to put that in perspective, one of our strategic competitors, China, is very much growing in their investments in science and technology. According to the OECD, their gross domestic expenditures in research and development over the last 15 years has gone up 409%. That's compared to 42% that ours in the U.S. has gone up. While their absolute value, they're spending roughly $600 or $500 billion a year in gross domestic investment in research and development, and we're spending about $600 billion. So we're still in raw numbers, absolute numbers, outspending them. But that rate of change, 400%, and just in the year 2019, which was the latest that the data was available, their expenditure in total R&D went up 10%, whereas ours went up more like 2%. So now that you have those numbers, you ask yourself, what's the risk of not investing in science and technology if our strategic competitors are aggressively investing in these areas? And that's where innovation comes from. That's where these new ideas, when you're spending money in science and technology, you see the nuance, details, the complexity, and then you also see how that could be weaponized or used to your advantage in a national power competition. So on the very big picture, I like to look at what's the risk of not doing something, and it really justifies some of our expenditures and basically.
Yeah, thank you. That it's an interesting piece. Often you think about the risk of doing something, and people think it about making a decision, but the absence of a decision or not making a decision or not taking action, that risk piece is very interesting. So when you talk about the China investment in terms of R&D and where it compares to the U.S., I can liken that also here in industry, where companies like Viasat and others have made significant investments. Their own IRAD, their own internal research and development fund is significant, and part of that's driven by the market, but the other part is that you're trying to get to a better way. Do you see one way potentially of buying down risk is that partnership with the government? Take advantage of industry, commercial investment. How do you discover those technologies? How do you understand those technologies? How do you gain access to those technologies? That may be a way in risk approaches, but I'd like to hear your thoughts on maybe some of those partnerships.
Yeah, those partnerships are very important, and particularly as technology becomes more global and the rate of change becomes faster, we just absolutely have to have partnerships with industry and in the commercial ideas and innovation that are happening. And we, frankly, from the government side, need to figure out how to be more agile to those ideas. Just like I just said, when we're stuck on our legacy architecture and can't implement these new ideas, that's a failure on our part. So we definitely need to take advantage of that. And in another place, in the Space Force is very much in the realm of science and technology, looking to academia as well, and partnerships between academia and industry to get basic and applied research off the ground and through the valley of death, so to speak. This is a little different than we've done this in the past, where the government was sort of daddy warbucks and had the big dollars to spend and drove research. You can think about the Apollo program driving space. Today, it's a lot different. We have commercial ventures that are off with their own goals and objectives, and they're going to solve problems that we haven't solved yet, and we need to take advantage of that knowledge, and we need to partner with industry. And the same goes with our allies. There's a lot of activity happening overseas that we need to get over our fear of using some of that technology because it wasn't invented here and put it to use.
It's interesting when you say I keyed in on the word you said, fear, and I think maybe it is a cultural piece. And as formerly in uniform and now looking here, is that in some cases you don't know what you don't know, and then in the other part is that if you aren't looking around, and like a lot of good scientists, you need somebody to kind of look over your shoulder and tell you, hey, you missed something, or what about this, or kind of that peer review. That partnership and collaboration, there's probably some areas that hold promise. Are there some areas that kind of come to mind that you've seen in industry that maybe hold some particular promise or benefit to the Space Force? Whether that's satellites, networks, communications, what have you?
Absolutely. And I think the proliferation of satellite communication bandwidth capabilities is just astounding. The whole expansion of commercial interest, if space is to become a viable long-term area of human endeavor, which I would argue that we're just starting down that road, it's got to be wealth streams have to be available there. There's got to be commercial reasons to being there, and that's where I think the interesting new technology will come from as businessmen and women try to figure out how to make money in space. For example, infrastructure in space and manufacturing in space. I mentioned already that the cost of launch has gone down by 2 orders of magnitude, but now the next thing to look at is what you're actually putting in space. And if we can figure out how, another way to get around this mission assurance and all the risk avoidance that we go into testing our satellites for environments, our acoustic and shake and vibe and all those things that we do. Well, what if we just bubble wrap the raw materials, send them up to space, and then assembled and manufactured the actual capability on orbit? That changes the whole dynamic. That's a game changer. Instead of having to be assured that your thing's going to survive launch. Now you just push it out the window, see if it works. If it doesn't, you pull it back in and try again. So it's those kind of commercial innovations that I think are really going to transform space in the future. And if we don't, from a government Space Force perspective, if we don't embrace those kind of new ways of thinking about putting capability in orbit, that's going to be much to our detriment. Even to take it further, someday we will be sourcing some of the materials that we would use to manufacture and assemble these things from space itself, say the moon. There's lots of heavy metals and things that we can mine from the moon. If we didn't have to launch those out of the Earth gravity well, that's a big win for us. And so, in short, there's just a lot of that kind of activity, a lot of commercial interest in developing that infrastructure. And again, we got to figure out how to get it into our architectures.
Yeah, definitely. As you start looking at architectures and more access to space, I think there's going to be all sorts of new things that we haven't even thought about. I know I've heard you use the term kind of the space after next kind of concept, and where we go kind of broadly that looks at different orbits and technologies. Of course, there's always, I think there's a responsibility side there in terms of space sustainability. How do we make sure the environment's accessible? And there's probably some science on just because you can do it, maybe you got to do it safely or do it cleanly. And I think that maybe there's some thought that can go into there, but it opens up a wide avenue of opportunities.
Yeah, absolutely. And that's, my office, for the Space Force, we spend a fraction of our time trying to do some of the strategic foresight to think what the future might be, and that's the Space Force after next. We have the Space Warfighting and Analysis Center, whose job it is to really design the force for the next 10 to 15 years. But where are we going beyond that? And again, it's like skiing down a hill. You don't want to be looking at your ski tips. You want to be looking way out ahead so that you can start getting ahead of that kind of thing. And so we do spend a lot of time, and it's thinking about the future of 20 years from now, which we call the Space Force after next. The problem and the challenge there is that it's not all about the technology. And I can't predict the future of technology any better than anybody else. But you can look at where the trends are going. You can look at not only technology, but society, the environment, think orbital debris and global climate change. Those are things we're going to have to face differently. The economics, whether it grows tremendously in the future, the politics, what are the geopolitical situation, and try to just incorporate a lot of those trends into a projection or a set of projections into the future, and think divergently about what the possibilities could be, and then invest in the science and technology that gives you the broadest set of tools to deal with that future. So again, we spend a lot of time thinking through that. It turns out to be that's a very cost-effective way to do science and technology. Again, if you can think far enough in the future, the investments in the science and technology, if you give them 10 to 15 years to accrue, is not that big money. The problem is if you ignore that and you get to this future that was somehow unexpected or a failure of imagination, now you have to employ some expensive, desperate fix to repair that problem. For example, today we're spending lots of money trying to make our systems more resilient. We have to do it. But again, had we thought through that early on, we would be in a better position today.
Yeah, you've got a tough job, and that it's predictive. Is that where are we on the continuum? What do you think are kind of the best bets or safe bets? And when you start thinking about that, when you think about Space Force after next and kind of planning for a future environment with who knows what variation will be kind of injected. Where are some of those big bets? Where do you think things we ought to look at long term? And second, I'll say also, what are your near term priorities today that kind of help those building blocks or stepping you towards this imagined future?
Well, yeah, and that's a great question. And so let me start with the near term. I already mentioned things like autonomy and automation and trust and cybersecurity. These are all things that are facing us today, and we need to shore them up. We need to be able to do our missions in an increasingly contested environment. At the same time, we're growing new missions, things like tactical ISR and the ability to provide data in a joint, all-domain, tactically and temporarily relevant timeframes. That's a lot of short-term things that we need to keep on and keep working on. One of the outcomes of our long-term strategic foresight work is that we've realized that the Space Force really has a bimodal problem, a two-part problem. The first problem is that the joint warfighters' demand for space services is just going up. We know that they're going to need higher bandwidth comms, more unjammable PNT, all of those things, and we're going to have to build the systems and the capabilities to support that, and we can't shirk that responsibility. At the same time, we also realize that space as a domain of human endeavor is growing just extremely rapidly right now. And we need to be in a position to be able to defend U.S. assets as humanity expands out there, to deal with the geopolitical consequences. But people may not realize, when we talk about going back to the moon, a lot of people think about NASA and Artemis, our historical challenges about getting things back to the moon. But in the next year, in the next 12 months, there are 5 international missions to the moon that are not U.S. There's Japan, South Korea, Russia, India, and United Arab Emirates all have missions to the moon this year. And so the number of players in that space is just growing. And while a lot of those missions are for civil exploration and national pride, some of them are developing technology that could be weaponized or militarized. And so we have to be on top of that as well. And so a lot of our long-term thinking is, how do we stay in front of that elephant that's in the room that's growing very rapidly? Just the expansion of not only the distances we go in space, but the number of national and non-governmental entities that are in that domain. And how does that affect the United States Space Force and how we prepare for that?
Thank you, sir. I have really appreciated the conversation today. I think that the audience is also, I've seen a few questions pop in and other things. So it has been a pleasure having this conversation with you. And I think as we start thinking of the future, dream big, and that imagination, the science and technology, and of course, industry partners like Viasat and others stand ready to collaborate and partner on imagining the unimaginable and doing the impossible. So thank you for your time, and look forward to seeing you back in Colorado.
Thank you, Fred, and thanks for having me today.
All right. Thanks.
Thank you, Doctor. We ditto what Fred just shared with us. You were just great. We can't thank you enough, and continued success, and certainly hope that you'll join us again down the road.
Absolutely.
Thank you so much, Doctor. And Fred,
thank you both.
Above and beyond, thank you again so much. You did it well. You hit it out of the park, and we certainly thank your good friends over at Viasat, our presenting sponsor, right? Step to your left, and they all can see that wonderful logo right behind you. Oh, well done. Well done. Like a well-tuned athlete. Thanks so much. We really appreciate it.